Alright, hello you nerds. So to say you want to solve this thing, x cubed equals 1. So how are you going to do that? So first of all, you may think you're just going to move it to one side and you're going to go x minus 1, x squared plus x plus 1 equals 0. Then so from there you get 1, and then whatever the solution to this is, quadratic formula, whatever. But that's stupid. That's like too slow. I'm going to show you a way to make it much faster. So what you want, first of all, we have to know the real imaginary plane. So here's the real imaginary plane. Same as an xy plane, but instead of x, we have the real part and the imaginary part. So instead of writing something like 1, 0, right, the corresponding point here, 1, 0, would be a single complex number with the real part being the x coordinate, 1, plus the y imaginary coordinate times I, because that's the imaginary part, plus 0i. In this case, this point just represents the number 1, obviously. If it were like 0, 1, it will be 0 plus 1i, which is equal to I. So, pretty easy. So, going back to x squared equals 1, what you want to do is you're literally just going to first draw a unit circle on this plane. I know this is really bad, but we have real and imaginary. You're going to start on 1, 0, because 1 is obviously a solution to this. And then you're going to draw a equilateral triangle and regular triangle, since it's to a third power, over here. And you're just going to find the corresponding points here, and those are going to be your solutions. So, for example, this point over here, right? This point over here would be, we have to use our like sine or trig, you know. Since the entire circle is 2 pi radians, this part would be 2 pi over 3. And this part would be 4 pi over 3, the angle here. And how does this help us? Well, if you know your unit circle, you will know that this part, this thing corresponds to cosine 2 by 3 and sine 2 by 3, which is, of course, negative 1/2 and square root of 3 over 2. And given our definition from before, that is going to represent the answer negative 1/2 plus square root of 3 over 2i. And similarly, this point will be equal to negative 1/2, minus square root of 3 over 2i. Well, and these three, we have 1, negative 1/2 plus square root of 3 over 2i, and plus and minus. Those are our three answers to x3 equals 1. And the cool thing about this is that it works for any power. So say we had x to the 5 equals 1, instead of drawing a triangle, we would draw a pentagon, which I am going to struggle to draw. But pretty much these 5 points are going to be your answers, and we can use the same way. It's going to be some slightly different numbers, of course, but we can solve them in the same way. And finally, we can talk about the notation of like these numbers. So you may have seen the equation e to the pi I equals negative 1. And notice how we plot this on the real imaginary plane. And we had an angle of pi. What number does this correspond to? This is negative 1, 0. So it's negative 1 plus 0i equals negative 1. And this notation actually works for any angle here. We have e pi I theta. No, not pi theta. I don't know what I'm doing. E I theta. And in this case, theta is just a pi. It's just cosine theta plus sine theta I. Really cool thing, right? So, for x squared, or example x squared equals 1, we can write our answers as e to the 0, which is obviously 1, e to the 2 pi 3 times I, right? And e to the 4 pi 3 times I. And those will be the two, correspond to the two values we solved for earlier. And again, this works for any power of equations like this. x5 equals 1, x6 over 1, of course, have to be positive integers. But yeah, you know. Woo!